So similar triangles. Similar is a word that we use in mathematics that has a particular definition in mathematics. You know what it means like for yourself in everyday language, but in mathematics it has kind of a specific meaning. And we're not going to worry about other things, but for triangles, what does a similar triangle mean? So I think this is our definition. Two triangles have two angles the same, so two angles equal, right? Equal measurements of angles. Then they're said to be similar. Right? So that's what we're talking about, similar triangles. And what else does it mean? It means the side lengths of the triangle are proportional. Okay, let me see if I can show you exactly what that means. It means that if you see these two triangles, this length is twice that length, right? 8 and 4. This length is twice that length, 6 and 3. And this length is twice that length, 10 and 5. So every length in the big triangle is twice the length that it pairs with in the smaller triangle. That's what it means to be a similar triangle. That's really important that you know that you understand that. That's basically what we use. That's the idea that we use to solve these problems. But this also tells us if they're similar, if they have this set up, the angles are equal. So this angle would be exactly the same. I know the lengths are smaller, but the angle measurements are exactly the same. So if this one's 30, that one's 30. If this one's 60, that one's also 60. And if this one's 90, which it is, then this one is also 90. They have to be exactly the same. That's what it means to be similar triangles. Does that make sense? What do you think about that? So if I'm looking at this little dot and this little dot is the diagram's way of telling us those angles are equal. And this tells us those angles are equal. And so if angle A equals angle M and angle B equals angle L, I can write that. So I'll say like A equals M, B equals L. That means that C also equals N. And that means this is an important statement. ABC is similar to LMN. This little sign right here is our sign for similar. And so we say triangle ABC is similar to triangle MLMN. Notice the order. Notice that MLN is not alphabetical. Why do you think that is? Very nice. So we wrote, it was A, then B, then C. So we went M, L, N. Right? We have to write them in the same order. And that is important. That's part of it. And trust me, that's part of solving these two. So it's not just about being picky. It does matter because that's like it communicates all of that. But it's actually going to help you solve these problems really easily if you write it in the right way. So every question you're going to start by finding angles that are equal. And I would say writing it down like that. And then we're going to write the similarity statement. And then we're going to use it to actually solve problems and find answers. Okay, so that's what similar triangles means. Here again is, so this is a different triangle, let's say. If triangle ABC is similar to triangle DEF, we can write this proportion statement. So take a look. Okay, watch really carefully because this is what you need to know. AB over DE, DE. So I took the first two of the first over the first two of the second. EF and BC, BCEF, right? And then CA and FD, CA and FD. They have to line up. And it'll make sense, I think, when we do a whole example, why and exactly what's going on. Any questions so far before we try an example? Do you have no idea what I'm talking about? before we do example, if you look at those, they look like they have kind of the same shape. One's bigger, but otherwise they're kind of the same shape, right? Like they look like they have similar kinds of dimensions. But if I drag it like this, look, they're not similar anymore, right? They don't look the same at all. Can I do the same to this one? I can't. Let's see if I can make them similar again. This thing is designed, we're going to play with this a little bit later, but it's designed to just kind of goof around with it, and it'll tell you. Oh, I really messed this all up. Okay. Maybe like that, and then there we go. Similar. So again, those ones look like they kind of have the same shape, I would say. And that's what we're talking about, is two triangles are similar. And the important thing to know is when that happens, the side lengths are proportional. And we can use that to solve problems. Okay, so let's take a look at the first question. Use similar triangles to find the missing side that's indicated. So in this case, we're looking for x, round to one decimal place if necessary. Can somebody tell me two angles that are equal in this picture? Ethan. A and K. And how do you know? Yeah, the little dot, right? So we're going to do that. A equals K. Okay, another one? Taylor?
B and J.
Awesome. Oops. A equals K. And so then the last one has to be the last two that are left. So that's C and L. So we happen to do A, B, C in alphabetical order. K, J, L isn't in alphabetical order. So we're going to write our similarity statement. Triangle A, B, C is similar to triangle K, J, L. You want to do this every time. I know it seems like a little bit of extra work, but trust me, especially at the start, it's going to help you just organize your thinking and make sure you get everything in the right order. The other triangles that we looked at, these ones are not so much because this one's a little tilted. But if they're like oriented the same way, it's easy to see which sides go with which sides. But in this case, it's hard to tell. None of the sides are twice the others. It's hard to tell which side goes with which. And so doing it this way helps us do that. Now we'll write a proportionality statement. So I'm going to start with AB and KJ. AB over KJ equals, and then BC over JL equals, and then CA or AC, the order doesn't matter, over LK. So you shouldn't have anything doubled there. Like you shouldn't have AB twice or anything like that. You should have three different ones, or AB and BA. Shouldn't go forward and backwards like that. Okay? And now what do? We sub in. So where's AB? AB is 5 over KJ, which is 13. BC is unknown, so I'm just going to leave that as BC. JL is also unknown, so I'm just going to leave that as JL. CA is 8. And KL or LK is X. Whoops. So all of that work was to get this statement. It's a proportion. In this case, I'm not worried about that. I don't need to find anything in there. And I don't know anything in there, so I just ignore it. I have to find X. So this is a question that I get every time we do this. Like you have to pick which of the three you're using. That's part of the process. You have to understand that, okay, so I know both numbers in that, so that's going to help. And I'm going to look for x, so I'm going to use the one with x. I'm going to pick those two, and I'm not going to worry about that one for now. And so then what I do, and sometimes you have to do this twice, so you'll see that in a moment. So I get 5 over 13 equals 8 over x. And I solve for x. And have you done this before? Does this look familiar? Yeah, you've done this before, right? We've done proportions already in this course. So how would you solve it? There's sort of two ways that you can do this. How would you do it? It's familiar. Now there's the trick. Can you actually remember how to do it? Yeah, good. That's one way that you can do it. Anybody think of another way? No? I think I know what you're saying, and we kind of can do that, but we have to do something first. Remember, if x is on the bottom, it's a little bit trickier. So you can flip both sides to put x on top. And then what do? I multiply both sides by 8 to get rid of the 8 on the bottom. And 8 times 13 divided by 5. That's what you were saying, right? Is 20.8. And we always use units, meters. That's my x. Any questions? Yeah.
Wait, so you just cancel it?
Yeah.
13 divided by 5?
8 times 13 divided by 5. So once you get all the stuff above, Adam, doesn't matter once I get to this stage. This is just an equation. And we're just solving it for x. Right? So it doesn't matter how we got there. It's an equation that we solve. So I decided to flip both sides. And then whatever you do to one side, you have to do to the other, right? So I did that. So I multiplied both sides by 8 to find x. Any other questions? All right, I want you to find the three angles that are equal in the next one. And if you can write the similarity statement as well, do that. Somebody tell me the three angles that are equal. Ethan? Yep. And why'd you go with x in the end?
Because I looked at the indication.
Yeah, very good. And it's funny how your brain can play, like this seems like a simple thing, matching shapes, like they do that in kindergarten. But your brain, once you like flip it and turn it, your brain starts to play tricks. It can be really hard to tell what side actually goes with which. That's why it's important to be really, really careful. Very good. And then the last one, obviously c equals y. Very good. So how do I write my similarity statement? Summer? Z, X, Y. Preserve that order. And now, like I said, I do AB with ZX, BC with XY, and then CA with YZ. Right? And doing it carefully like that is what allows me to make sure I get the proportions correct. Some people are better at visualizing this stuff, and it comes very naturally to them to like see what goes with what and do this over this, this over this, this over this, and they can just do it. But a lot of people aren't like that. All right. So you can write your proportionality statement as well. See if you can do that. And then the next step. Nice, sub in the numbers. So so go ahead and do that. Hey, did you end up with that? Look carefully, please. The order counts. All of the three measurements on top are from the ABC triangle. And all of the three measurements on the bottom are from the XYZ triangle. And that has to be the case. You can't mix and match. Again, that's why doing it this sort of formal and careful way really, really helps. All I can tell you is people make this mistake all the time when they try to skip these steps and go straight to this statement. That's what people try to do. They just put 17 over 38 equals m over 13 and try to solve it. But that's upside down. You make that mistake, I mean, you lose at least a mark, right? Probably more, in fact, because your answer won't make any sense. So keep that in mind. It slows you down, and if you're careful and you do it this way, then you'll always get this right. But that being said, if you are awesome at visualizing, I would recommend you do this once or twice. Again, not now, but later in the year, we're going to revisit this, and it's going to be quite a bit harder. And when we do that, you're probably going to want to do this, okay? Because it's going to be that much harder. And so if you practice this a couple of times, you'll remember it. But if you're awesome and you're getting it, you can jump straight to this step. If you get it wrong once, you're on your own. You're losing lots of marks. Keep that in mind. Okay, so now what do I have here? I'm supposed to find m and n.
Could we do it twice? So we do 17 over 38 equals 13.
Awesome. 17 over 38. Whoops. I'm going to do it like this. 17 over 38 equals 13 over m. Yep.
And then we do another one
Yep.
to solve for n.
Right. So again, 17 over. Now, why do you pick 17 over 38?
Because it's easier to, because it has the two numbers.
It's got both measurements. You need to use at least one of those fractions that has two measurements in it. Does that make sense? Now you got two questions to solve. So this one, again, m is on bottom, so you could flip it first. And the other one, n is already on top, so that'd be really easy. Multiply both sides by 29.5 and go. Any questions? All right, I don't think you need to see another one.